Welcome back to my channel. This is gonna blow your mind. I bet you didn't know how machine learning really works. When we hear the term machine learning, it's easy to imagine robots thinking like us. We picture them understanding the world and learning new things just like humans.
The truth is a bit more complex. Machines don't learn in the same way we do. They don't have feelings or experiences that shape their understanding. Instead, they rely on something quite different: mathematics.
At its core, machine learning is about finding patterns in data. Imagine a massive spreadsheet filled with numbers and information. A machine learning algorithm can sift through this data, looking for connections and relationships that we might miss.
By using clever mathematical formulas, these algorithms can identify trends and make predictions. They learn from the data they are given, but not in a conscious or sentient way. Instead, they are incredibly powerful tools that can help us make sense of the world around us. Let's imagine we are teaching a machine to recognize pictures of cats. We start by feeding it thousands of cat photos. The machine analyzes each image, breaking it down into pixels and analyzing their colors, shapes, and patterns. Through a process called training, the machine begins to identify features that are common to most cats: pointy ears, whiskers, a fluffy tail. It uses mathematical equations to represent these features and their relationships to each other. This mathematical representation is called a model. The model is like a set of instructions that tells the machine how to recognize a cat. When we show the machine a new picture, it uses its model to analyze the image and calculate the probability that it's looking at a cat. The more data we feed the machine, the more refined its model becomes. It learns to recognize subtle differences between breeds, identify cats in different poses, and even distinguish a cat from a fluffy dog. Imagine you're trying to find the lowest point in a vast hilly landscape. One way to do this is to walk over every inch of the terrain, carefully comparing each spot until you find the absolute lowest point. This is essentially how brute force methods work in computing. They explore every possible solution to find the best one. But this can be incredibly time-consuming, especially with complex problems.
Machine learning often uses a more elegant approach called gradient descent. Imagine rolling a ball down our hilly landscape. The ball will naturally move downhill, following the steepest path until it reaches a low point. It might not be the absolute lowest point in the entire landscape, but it will be a good solution found much more efficiently.
Gradient descent works similarly. It starts with an initial guess and then iteratively adjusts its parameters, moving towards a solution that minimizes errors. This approach is much faster than brute force, especially when dealing with massive datasets and intricate models.
Once our machine learning model is trained, it's ready to put its knowledge to the test. We can show it new, unseen images, and it will use its learned patterns to make predictions.
If we show it a picture of a furry creature with pointy ears and whiskers, it will likely tell us it's a cat, even if it's a breed it's never encountered before. However, it's important to remember that the machine is simply applying the patterns it learned from the training data. It's not dynamically adapting its understanding or thinking critically about what it sees.
If we start showing it pictures of cats wearing hats, it might get confused. It hasn't learned that cats wearing hats are still cats. To adapt to this new information, we would need to retrain the model with additional data, including images of cats in hats.
Data drift and the need for retraining. The world is constantly changing, and so is the data that represents it. Imagine our cat identifying machine learning model was trained on images from 10 years ago. Back then, certain breeds might have been more popular, and cats might not have been as commonly dressed up in costumes. Over time, the types of cat pictures shared online might change. New breeds might emerge, and people might develop new trends in cat fashion. This change in data patterns is called data drift. Data drift can cause problems for our machine learning model. If the patterns it learned no longer accurately reflect the current reality, its predictions will become less accurate. It might start misclassifying cats or struggling to identify new breeds. To combat data drift, we need to periodically retrain our model with fresh, up-to-date data. This ensures that its knowledge stays relevant and its predictions remain accurate.
Traditional machine learning models, like our cat identifier, learn from a fixed dataset and then apply their knowledge to new data. But what if we could create models that continuously learn and adapt in real time? This is the idea behind online learning.
Imagine a self-driving car navigating a busy city. The environment is constantly changing, with new obstacles, pedestrians and traffic patterns emerging all the time. An online learning algorithm could allow the car to adapt to these changes on the fly.
Instead of relying on a fixed set of rules, the car would continuously analyze its surroundings, learning from its experiences and adjusting its behavior accordingly. It could identify new types of vehicles, anticipate pedestrian movements, and navigate unfamiliar roads, all while driving.
Online learning represents a significant step towards creating truly intelligent machines. By enabling models to learn and adapt in real time, we open up a world of possibilities for automation, personalization, and problem solving.
Machines that evolve. So, do machines really learn? The answer is both yes and no. Traditional machine learning models don't learn in the same way humans do. They don't experience the world or develop an understanding based on feelings and interactions.
Instead, they are incredibly powerful tools that use mathematics to find patterns in data. They can learn from the past, make predictions about the future, and even adapt to changing circumstances with techniques like online learning.
As we continue to develop more sophisticated algorithms and feed them ever-growing datasets, the line between machine learning and true artificial intelligence will continue to blur.
We are entering an era where machines can analyze vast amounts of information, identify complex patterns, and make decisions that were once the sole domain of humans. The future of learning is no longer limited to biological brains. It's a future where machines and humans learn alongside each other, pushing the boundaries of knowledge and reshaping our understanding of intelligence itself.